On this video, we are going to be looking at second derivative implications. Remember that second derivatives, they talk about concavity. So it is important to name that f double prime of x, when that is greater than 0, we're concave up. F double prime of x is less than 0, concave down. Also, those point of inflections come from f double prime of x equals 0. So let's get this done. What are all the values for x for which the graph of y equals yada yada is concave down? So again, we are looking for f double prime of x being less than 0. So here's my y prime. Let's get that first derivative. We're going to rewrite this as 6x to the negative 1. So that should be a negative 6x to the negative 2 plus 12x. So 12x to the negative 3 plus 12. Again, setting this guy equal to 0, and I'm going to rewrite. So I'm going to say 0 equals 12 over x cubed plus 12. And then I'm going to move this guy over. So I'm going to have negative 12 equals 12 over x cubed. Cross multiply here. And I get x equals negative 1. Remember that it is also important to note where that derivative is 0. So we're also going to be looking at 0 when I'm looking at my sign chart. So that equals 0, and then that undefined point occurs when x equals 0. So remember, 0 or undefined. So we are checking negative 1 and 0 and looking at what's going on with values between these. Well, I know if I plug in, let's see, if I plug in anything that's above 0, right? So if I have 12 divided by 1 cubed, I would get a positive value. If I do anything between negative 1 and 0, 12 divided by negative, we know when we divide by a fraction, or I guess a fraction's a bad word. We know when we divide by a number less than 1, we're making that value larger. And so that will be a large negative number, a larger negative number than 12, and we're going to be adding 12 to that. So that would give us a negative value. Then if I'm dividing by a value greater than 1, that's going to be decreasing the size of that 12, so that'll be a smaller value than 12. It'll also be negative plus 12, which is going to still give us a positive value. And if that felt very confusing, you can just plug in a few numbers on your calculator to verify that. So for example, if I am saying, let's go back to that equation, 12 over x cubed. If I were to come in here and say this were 12 over, let's call that negative 2 cubed. We know that that's going to be a small fraction, but it's still going to be positive. I messed up here, plus 12. Also, if I take that though, and let's put in that value that's less than negative 1 or between negative 1 and 0. So let's call that like negative point, let's call it 8. That's still going to give us a negative value. This means that we are concave down from negative 1 to 0, which is answer choice C. Find the value of k if the graph f of x equals 3x squared minus k to the x has an inflection point at x equals negative 1. So we're already seeing that the inflection point is at x equals negative 1. This means that f double prime of negative 1 equals 0, right? Because an inflection point is where that double derivative equals 0 and changes signs. So let me expand this a little bit, give us some room. Let's get that double derivative. That single derivative, we're going to have f prime of x equals, I'm going to write this as negative k times x to the negative 1. We're going to have 6x plus kx to the negative 2. And then that double derivative is going to be 6 plus negative 2k x to the negative 3. Rewrite that. And then we'll substitute that negative 1. So f double prime of negative 1 equals 6 minus 2k, negative 1 cubed is negative 1, which is 6 plus 2k. So then I'm just solving for k here. I know that that f prime of whatever is also equivalent to 0. So if I were to solve this, we get negative 6 equals 2k, and k equals negative 3. Identify the intervals where f of x is concave up and concave down, and identify all points of inflection. All right, same thing. We're looking for that double derivative to give us information about the concavity of f of x. I know that f prime of x is going to be 4x cubed minus 18x squared, and f double prime of x gives us 12x squared minus 36x. Factor out that GCF, which would be 12x. And my solutions are 0 and 3. Again, plotting these guys right here. This is a quadratic and it's concave up, right? So I know that these two zeros have a multiplicity of 1, which means I'd be crossing the axis. So I'd be positive, negative, positive. Concave up is going to happen from negative infinity to 0, union 3 to infinity. Concave down is occurring on that middle interval where the double derivative is negative. So we have up, down, up. So 0 to 3. And my points of inflection are where is that actually changing concavity? And this is going to be at x equals 0 and 3. Last one here. Suppose f double prime of x equals 4x cubed minus 2x, and the critical values of the function f prime of x are negative 1, 0, and 1. Use the second derivative test to determine which critical numbers, if any, give a relative maximum. All right, so these critical numbers are where f prime of x equals 0. If I think about where f prime of x equals 0, right, we have 0 here, 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 looks like a little 0 here. So these are all potential critical values, and the second derivative is going to tell us if it's concave up or concave down. If we're looking for a relative maximum, we want that f double prime of x to be greater than, less than 0, because that would indicate concave down and give us a maximum. So let's try it out. We want to know what is f double prime of negative 1, what is f double prime of 0, and f double prime of 1. And remember, I don't care much about the exact value. I care more about the sign of that value. So we have 4 times negative 1 cubed minus 2 times negative 1, 4 times 0 cubed minus 2 times 0, and then 4 times 1 cubed minus 2 times 1. This is going to be a negative number and a positive. So right here we have negative 4 plus 2. So this is going to be negative. This guy right here is going to be 0. And then this guy right here, so that's neither a min nor a max. And then this guy right here gives us what? 4 minus 2, so this is a positive number. So I'm going to say here, at x equals negative 1, f of x has a relative max since f prime of x equals 0 and f double prime of x is less than 0. Because what we're saying here is we are concave down, right? Less than 0, concave down, and we have a slope of 0. Both of those conditions satisfy maximum.